Hey y'all. Today we're going to take a look at simplifying rational expressions. So yesterday we took a look at their functions, talked about domain and range and different things like that. Today we're actually going to work more with some problems and simplify these rational expressions. So when you simplify a rational expression, you factor the top, factor the bottom, and see what cancels. So that's going to be the take home point for today. So we are going to factor the top, factor the bottom, and then see what cancels. So this is the take-home point for today as far as simplifying rational expressions. Factor the top, factor the bottom, see what cancels. So that foldable that we made back real long time ago that has the different factoring things and the four-step method and the factor tree and all that good stuff, you may want to pull that back out to help you kind of refresh your memory with factoring. So we're going to factor the numerator, factor the denominator, and then see what cancels. So let's start with the first one. So if I break down 4x, that breaks into 2 times 2 times x. If I break down 20, that's 4 times 5, and 4 is 2 times 2 times 5. So I factor the top, I factor the bottom. Now, anything that's the same in the top and the bottom, you're going to cross out. So that 2 and this 2, this 2 and this 2. So we're left with x divided by 5. So that is our final answer. You factor the top, factor the bottom, see what cancels. All right, let's move on. So I have several examples that we're going to be doing today to refresh our memory with factoring because it is a lot of factoring involved with this. Number 2, pull out your greatest common factor. That's your first step when you do any kind of factoring. My greatest common factor is 2. Left over, I have 3 plus x. The great thing with factoring is that you can check yourself by just multiplying it back out. 2 times 3 gives me 6, and 2 times x gives me 2x. On the bottom, we set up our 2 sets of parentheses, and we are thinking of 2 numbers that multiply to give me positive 6, add to give us 5. So multiplies to give me positive 6, adds to give me 5. Those numbers are 3 and 2. If you have the same factor on the top and bottom, it cancels. So these are the same, even though the order is different. I still have a positive 3 and a positive x. So the commutative properties tells me that those are the same. So they're going to cancel out because I have the same thing. So left on top is 2, and left on bottom is x plus 2. You can't cancel out these 2's because 1 is over addition. And so you can only cancel things out that are being multiplied. So this is my final answer for number 2. All right, moving on. Number 3. So number 3 is what I say, I call it factoring like normal with the 2 sets of parentheses. So we can go ahead and set those up. We can go ahead and fill in our x's. All right, in the numerator, we need 2 numbers that multiply to give us negative 20 and then add to give me positive 1. So that should be negative 5 and positive 4. And I actually need to flip my sign, so positive 5 and negative 4. So positive 5 times negative 4 gives me negative 20. And then when I add these together, it gives me positive 1 in the center. So again, this is a positive 5 and a negative 4. So be careful with your signs there. And then on the bottom, I need to do the same thing there. I need to factor 2 numbers that multiply to give me negative 15 and add to give me 2. So 15 is what, 5 and 3. So let's do 5 and 3. So we'll check ourselves. 5 times negative 3 is negative 15. We're good there. And if I add those, I get a positive 2. If you have the same thing on the top and bottom, it's going to cancel. So x plus 5 goes away. So we're left with x minus 4 over x minus 3. So that is our final answer. Now, number 4 is the 4-step method. So I wanted to refresh our memory with the 4-step method. So again, if you have that foldable, you can go through those 4 steps there. So when I factor the top, it's going to factor into the 4-step method. So I am going to work out the 4-step method in case it's been a little while since you've done it. And I'm going to do my work down here. So this is just a side note. So the four-step method, multiply the first and the last number. Okay, step 2, we're going to factor like normal. So we'll set up our parentheses. Two numbers that multiply to give me negative 12, add to give me positive 11. Okay, step 3, step 3, divide by the first number in the problem. So I'm going to divide by 2. So now we have x plus 6 times x minus a half. And step 4, get rid of fractions. And you get rid of fractions by multiplying by the denominator. So I'm going to multiply just this part by 2. So it'll be x plus 6 times 2x minus 1. Again, just for the numerator, a little bit of review mix in here. For the numerator, if you have a different coefficient in the front, we went through and we did that four-step method that we talked about a few weeks ago. So multiply the first and last number, factor like normal, divide by the first number in the problem, and then get rid of fractions. So this is now my numerator. So I now can put this in the top of my fraction. So 2x squared plus 11x minus 6 factors into x plus 6 and 2x minus 1. And my denominator is x plus 6. Now, if you have the same thing on the top and bottom, it cancels. So x plus 6, we're left with 2x minus 1. So that is our final answer for number 4. Just before I forget, if you had a case where nothing canceled, that would be okay. So don't feel like just because nothing did cancel that you did something wrong. So if you do factor the top and factor the bottom and nothing cancels, that's okay. Just leave your answer in factored form. All right, number 5, pull out your greatest common factor. So my greatest common factor is 3. On the inside, we got x plus 4. On the bottom, we'll factor like normal, set up our parentheses, and put our x's in there. We're trying to think of two numbers that multiply to give me negative 20 and add to give me negative 4. So those numbers are negative 5 and positive 4. So I have something that cancels, so I'm going to mark that out. Final answer, 3 over x minus 5. Now, so far, our factors have been exactly the same. So we haven't had any need to do anything or switch the signs or anything like that. The first 5 problems that we've done, we've factored the top, we factored the bottom, something canceled. I want to take a look at what happens if your signs are off, as in like positives and negatives. So if I look at number 6, our signs are off just a little bit. And what I mean by that is my numerator is x minus 4. And if I put this in the same order so that my x is first and the number is second, it's going to give me negative x plus 4. So this gives me negative x plus 4. So these are only differ by the sign. This is positive, this is negative. This is negative, this is positive. So when things differ by a sign, I want you to factor out a negative 1, because multiplying by negative 1, all that does is change the signs of your terms. So this is going to give me x minus 4. I'm going to factor out negative 1. When you factor out negative 1, it's going to change your signs. So notice in the denominator, I factored out negative 1. And then now my signs are exactly the same. So you can double check yourself, because negative 1 times x is negative x. And negative 1 times negative 4 is positive 4. But now my signs are exactly the same. I got a positive x, negative 4, negative 4. So that cancels. Left on top, you may think there's nothing left on top, but there's a 1 that's left on top. And on the bottom, there's a negative 1 that's left. So 1 divided by negative 1, our final answer is negative 1. So this problem, we had to factor out a negative 1 so that my signs would match up, so that everything was exactly the same, because that's the only way that you can factor something out. And I'm going to do another one of these where we have to factor something out. Okay. Number 7. So I'm going to leave the top like it is. There's nothing I can do with the top, so that's going to stay 8 minus m. On the bottom, we're going to set up our parentheses. Go ahead and fill in the m's. We need two numbers that multiply to give me negative 64, add to give me 0. So in the denominator, there's no m term. So we're looking for two numbers that multiply to give me negative 64, add to give me 0. So those numbers are negative 8 and positive 8. Negative 8 and positive 8. Now, this is another case where my signs are off just a little bit. So this is negative m, that's a positive m. This is positive 8, that's a negative 8. So if we factor out a negative 1, that'll help us a lot. So this is what I'm going to do. I'm going to write the m term first so that you can clearly see that they differ by a sign. So on top, instead of having 8 minus m, I'm going to write negative m plus 8. And then on the bottom, I'm still going to have m minus 8 and m plus 8. Now I'm going to factor out a negative 1 because now I can clearly see that these are almost the same. I can almost cancel them out, but I need to make sure their signs are the same. So I'm going to factor out a negative 1 on the top. So on top, I'm going to have negative 1, m minus 8. And then on the bottom, I still have the same thing that I've been carrying throughout the problem. Now my signs are exactly the same. Positive m, negative 8, negative 8. So I can cross those out. On top, we're left with negative 1. On bottom, we're left with m plus 8. And that is our final answer. So factor the top, factor the bottom, see what cancels. Factor the top, factor the bottom, see what cancels. Last one got a little kind of like a challenge problem here. This one's a little harder, but we can tackle it together. We're going to factor the top for number 8 and then factor the bottom. So I'm going to go ahead and set up my parentheses. Okay, so we'll go ahead and set up our parentheses. These are perfect square numbers. So since these are perfect square numbers, they're going to factor into the same expressions, except for it's going to be a plus or minus in the middle. So it's going to factor how we did the m squared minus 64. It's going to be the same factor, but one's going to be minus and one's going to be plus. So when I factor this, one's going to be minus and one's going to be plus. 36v squared is 6v and 6v. 49w squared is 7w and 7w because they're both perfect square number. One's positive, one's negative. So that is our numerator. 6v plus 7w and 6v minus 7w. Now on the bottom, I can set up my parentheses. I need two things that are going to multiply to give me 18v squared, and then it's got to multiply here to give me 14w squared. Now be careful here because we're doing the box method distributive property backwards. So we're going to have v's and w's in our problem. So this factors into 3v minus 2w and 6v plus 7w. And if I were to multiply all this back out, it would give me 18v squared plus 9vw minus 14w squared. Last thing we need to do is cancel out anything that's the same. I see a 6v plus 7w here. I see a 6v plus 7w here. So our final answer is 6v minus 7w over 3v minus 2w. So number 8 was a bit of a challenge problem. I wanted to stretch ourselves out there a little bit as far as factoring goes. But the take-home point for this is you're going to factor the numerator, factor the denominator, and see what cancels. One more time, factor the numerator, factor the denominator, and then see what cancels.